In this lesson, we are going to learn about experiments, and in particular in this lecture we are going to learn about the role of experiments in improving the performance of the output parameters that you're trying to improve. I hope you remember the days when as a child you used to play around with the antenna in your house, adjust the various elements of the antenna to get the desired signal, to get the desired channel in your TV. What was that? That was nothing but a simple experiment of changing various variables to get the desired output. As rough as it might sound, that was one of the best ways to ensure that the output is optimized. Coming to business, we may not need to adjust antennas, but we may have to improve the output or yield of the processes. The improvement parameter that you're working on will have to probably be optimized to get the desired output. Identifying what the root causes are could be done earlier, but having done the identification of root cause, you may want to optimize it right now. Sometimes experiments can also help you to pinpoint the root cause. Let's take an example of a soya oil manufacturer who wants to increase the yield of his plant. So the input for this is nothing but the soya bean itself. The process is a bit complicated. It involves cracking the soya bean at adjusted moisture level and then taking it to a temperature of around 140 to 190 degree Fahrenheit. After that, flakes are rolled and it's then used with a solvent to extract, a solvent of hexane to extract the oil. Now, in this process, the manufacturer wants to improve the yield of the process. Thus, this becomes an ideal case to play around with various parameters in the process to get the desired output. If we step back for a minute from this example, experimentation arises for various reasons. Firstly, we may want to do experiments to find out which factors impact the output. If we know what factors impact the output, then we may want to understand the nature of relationship between them, that is the X and the Y. If we know that, we may also want to quantify the impact on Y. Some cases, two or more factors, two or more X's jointly might have an impact on the output, and we may want to find out in such cases which are those two factors and what is the impact they have. And finally, if we know all this, we may be able to propose an optimal setting of the input parameters, the factors, so that we can get optimal output value. That is exactly the scenario for us with this case of oil extraction from soya. Traditionally, experiments are done using trial and error. If you take the example of adjusting the antenna to get the desired channel, that is done by trial and error. So the person who is doing that over a period of time gets the expertise, and so he is able to obtain the desired output. The other disadvantage with traditional method is that varying more than one factor would be difficult. Thus, each factor is varied and then the other factors are kept constant, and likewise the experiment is carried out one factor after the other and then the optimal values are identified. Now this could be laborious and sometimes may not give you the desired outputs. On the other hand, structured experimentation involves statistically valid methods through which more than one factor can be varied at a given point of time. Thus, a structured experimentation is more efficient than traditional experimentation. As we move forward, we will learn more about structured experiments, but I want to reiterate that in structured experimentation, which is called as design of experiments, we will be able to vary multiple factors at the same time, thereby reducing the effort needed to perform the experiments and also reducing the cost and time needed. So what is design of experiments? Design of experiments is nothing but creating a design through which you are able to vary various factors in your experiment Thereby, you are able to reduce the number of trials, number of experiments that you need to perform without compromising the quality of the experiments. So that kind of an optimal design as to how many number of experiments needs to be done, which factor has to be set at what level, and how do we measure the output, etc. is what we call as design of experiments. Let's look at some of the important considerations for design of experiments. Firstly, we should be able to change the process setting without impacting the live process or the customer. In case you're dealing with something that's customer facing, it might be very difficult to go and change the various parameters of the process, because we know as we change the parameters, it's going to impact the output of the process, and if that's a live process, then performing experiments on a live process is very dangerous. So one of the prerequisites should be that you should be able to create an experimental setup through which you are able to do the experiments. Necessary resources have to be provided for you. Because it's a separate experiment, you need all the necessary infrastructure through which you can perform the experiments, which is isolated from the core production or live process area. Sometimes experiments may run to a couple of days, sometimes to a couple of weeks, or even sometimes to a couple of months. Depending on the nature of the experiment, we may need to ensure that the experimental conditions are not being disturbed, or to some extent we are able to maintain the experimental conditions. If the experimental conditions get disturbed, then the accuracy of the experiment will be compromised, or in other words, we may need more time, more experiments that we need to perform before we are able to conclude. So maintaining the experimental conditions is one of the considerations if you want to pursue DOE. Now coming to the last point, in some cases we may not be able to get the data without altering the various parameters. In other words, without performing an experiment, we may not be able to collect the data because our process may be locked for that particular parameter. For example, the service level. You may not be able to go and change the service level of your process, or you may not be in a position to change certain regulatory parameters because they have been locked. In such scenarios, an experiment will be more convenient because we may be able to change the parameters and we may be able to prove the concept in that experimental setup. These broadly define what are the various considerations if you want to take a DOE. Now moving to a very important and pertinent point relating to the relevance of DOE. Most often when I talk to people who are pursuing their advanced course or their Six Sigma Black Belt course, they think that DOE is primarily meant only for manufacturing folks. And in manufacturing, people always think that if you don't have a DOE in your project is not a project in itself. Both these assumptions are incorrect. DOE has a lot of application in service sector. If you take the whole concept of design thinking, it's based on creating experimental setups through which you are able to validate your hypothesis and then implement it using proof of concept or pilots, which means we are proposing that even in service sector, we should be in a position to perform various experiments and get the desired output rather than experimenting with the live process or with the customers directly. So where can I apply DOE in service sector? You can apply it whenever you want to design your processes or products. It could be to do with user interface designs or marketing campaign designs, or you want to design the touch point of your customer interface, or in cases where you want to optimize the setting of your process, the performance of your process, then in such cases you can again use DOE. It could be to do with sales performance, it could be to do with customer satisfaction improvement. So in many of these cases, you may be able to perform experiments. Then once you know what the optimal settings are, that can be baked into the existing process so that we are able to obtain the desired outputs, so that we are able to deliver the best for the business or for the customer. As far as manufacturing folks are concerned, I can tell you that it is not mandatory for you to perform design of experiments in your project for you to get certified as a black belt. In many situations, as I described earlier, a design of experiment may not be possible. In some cases, doing an experiment itself may not be viable because you're dealing with live process, and in a live process what matters is live data. In such cases, if you're able to prove something in an experimental setting but your optimal setting cannot be replicated in live environment, then it doesn't make sense for you to go and do the DOE on the first place. So I would wrap up this introductory lecture by stating that DOE is an advanced tool, and it's very important for you to recognize when, where and how a DOE has to be applied. In the following lectures of this lesson, we will talk more about design of experiments. Thank you.